Did you know that you can use SQL to query data frames when you're using Marimo Notebooks? We're going to dive in and show how to do that in this video, and we did a previous introductory video on Marimo Notebooks. You can find that in the description. What we're going to do in this video is take that data frame that we created before, and we're going to query that and perform some analysis using SQL. So let's get started. We have a documentation open here on using SQL inside a Marimo notebook, and it turns out that these notebooks have SQL cells, as we're going to see in a second. So you can mix and match Python and SQL in your workflows, and you can use SQL to query Python data frames, for example in Polars or in Pandas. You can also turn your results into Python data frames as well from these SQL queries. Now, to actually use the SQL cells, you need some additional dependencies, and Marimo comes with some SQL extras, and basically that's going to install DuckDB. Now, we did a video on DuckDB before if you want to know more about how to use that to query data frames using SQL. What we're going to do now is, using UV, install the Marimo extras. So let's do that just now, and I'm going to go to the terminal here and paste this command in, and you're going to notice that when we install these SQL extras here, what it does is download and install DuckDB into the Python virtual environment that we created using UV in the previous video. Now, we've got the link to how to use DuckDB in the description of the video, and we also have a link to our Ko-fi page, so if you want to support the channel and you find this content useful, then you can find that link there, and any support for the channel is greatly appreciated. Now, after you install these SQL extras, if you're using Pandas data frames, you're good to go. If you're using Polars data frames, there is one extra dependency that you need to install. So I'm going to go to the DuckDB documentation on integration with Polars. Now, Polars basically uses the 𝗵𝗽 columnar format as its memory model, and this is different to Pandas, although I think the modern versions of Pandas also have support for this. But in order for DuckDB to read Polars data frames and convert query results back to Polars data frames, you need to install the 𝗵𝗽 library. So let's go back to the terminal here, and one last installation that we're going to do here with UV. So it's UV pip install, and it's 𝗵𝗽 that we're going to install here. Once we've installed that, we can get started and take the data frame from the previous video and start querying that using SQL, and we're going to perform some analysis of that data frame very soon. So now that we have the dependencies installed, let's run the notebook. So it's the UV run marimo edit command, and we provide the name of the notebook, and it was test_app.py that we created in the previous video. When we run that, we're going to get a link to actually open the notebook in our browser. And notice as well that you have the option of upgrading Marimo if an upgrade is available here. But let's now go to the notebook that's open in the browser. So we're now in the notebook that we used in the previous video, and you can see the notebook name here, test_app.py, and we also have languages.csv. That was the data file that we were reading in, and using that as our data frame here, as you can see, using the polars.readcsv function. Let's now use our new SQL capabilities in this notebook. So what I'm going to do is just scroll to the very bottom of what we added in the previous video, and notice that you can add a Python cell, you can also add a markdown cell as we saw before. But there's another option here, and that's the SQL cell. We're going to do that just now. We're going to add an SQL cell, and then we get this skeleton for a select statement. So what I'm going to do from our data frame is just select everything. So select all from DF, and DF refers to the data frame that we created just up here using polars.readcsv. So we can take the name of that variable and we can query that with this select statement. So let's execute this, and we're going to see what happens. We get back the data frame in the same format as we did when we were using Python. So we can now query the data frame using SQL, and that's very convenient for any data analysts or engineers that are familiar with SQL but might not know Python or Pandas or Polars. And we can perform more complex queries here. So let's add a where clause, and what we're going to look for is the date column. Let's say we wanted all results where the date was equal to August 2004. And at the moment the date is represented as a string. We're going to change that to a date data type very soon. But let's execute this, and we get back a single row that represents the data from August 2004 for all of these programming languages. Now, some people did comment in the previous video that they prefer the cell output to be below the cell where you write the code, rather than above, as you can see here, and it turns out this is configurable, and we're going to see that at the end of the video. So if you want the output to appear below the cell where you're writing the code, we are going to show how to do that at the end of the video as well, using Marimo configuration. Now let's say we're interested in Python again here, so rather than selecting every column, what we're going to do is select two columns. One is the date, and the second one is the Python column. Remember, each column in the data frame has the name of a programming language, and I'm going to remove the where clause for the time being. Let's execute this, and we're going to get back a data frame that contains two columns, the date and Python. And remember, these scores here represent the Python share of popularity amongst these programming languages for the given month. So let's imagine we're given a problem to calculate which year Python's popularity increased the most compared to the previous year. So for example, in July 2004, we had a popularity of 2.51, and then in August it was 2.62. That represents an increase of 0.11. But we want to find out which year did Python increase popularity the most, and we're going to use SQL to find that out. And we're going to build up an SQL query that uses common table expressions and subqueries in order to do that. Now I want to start by converting this column here to a date data type. So what I'm going to do is go to the top here where we actually read the CSV file, and after that I'm going to chain another Polars function, and that's the _columns function, and we're going to pass an array into that. Now what we want to do in order to convert this to a proper date is we want to take the month and the year, and I'm going to add the first day of the month to that. So July 2004 is going to become 1st of July 2004. Now in order to do that, to with columns, what we're going to pass in here is the string 1 and then a space, and then we're going to concatenate pl.call, and we're going to add the date column value into that. So that's just going to take the existing date from the CSV and it's going to add the first of the month to that. Once we've done that, we can use more functions in Polars. So we're going to use the string.stringParseTime function, and we're going to parse the column to a polars.date data type, and we're going to pass a format into this. Now the format has the day, and it's going to be the first of the month because we've hard-coded that above, and then we're going to use %b, which represents the full month name, and then a space and %y, which represents the full year. So that's going to match the format of the 1st of July 2004 and all of the other dates that we have in that column. So we've converted that to a Polars date type, and then we're going to alias the result here using .alias, and we're going to give that the column name of date. So we're just changing the way we're reading this in to convert the date to a proper Polars date data type. So let's execute this cell, and we get back the result here, and you can see the data type up here has changed for that column to the date type. So I hope that makes sense, but that is going to break some of the other functionality that we did in the previous video. So as an exercise, you can go back and change some of that to make that work again. But what we're interested in now is re-executing the code down here. And remember from the previous video, we don't actually need to manually do this. And that's because Marimo cells react whenever any dependencies change. So DataFrame has changed here, and you can see here we get the change represented in the output. Now I'm going to separate this into new lines here because we're going to add some slightly more complex statements here. And in order to compare the value in a row to the value in the previous row, we're going to make use of an SQL window function called lag. So let's find out more about this using the Neon Postgres documentation. The lag function allows you to access the data of the previous row from the current row. And this can be useful for these kind of comparisons of the value in the current row against the value in the previous row. So we're going to make use of that, and let's go back to the Marimo notebook in order to do that. Now I'm going to add a column here called previous popularity, and we're going to fill the value for that now. So previous popularity is going to be by using the lag over the Python column. In other words, in the select statement, we're getting the previous value in that Python column. That's going to be using the lag, and we're going to use an over statement here, and we're ordering by the date column. That's just going to make sure that the values are in order. And we know that they are going to be in order now because we converted the date column to the date data type. So it's not going to be a character column which is going to order alphabetically. It's now going to order properly by the date. And we can alias that as previous popularity. And I need to add a comma in between these column names. So now we should have 3 columns in the resulting data frame. So we can see that here. And for each date here, we get the current value of Python's popularity, but we also now have the previous, and that references the value in the previous column. And that's because we're using that lag function. Now, one thing to note is that for the first row in the data, there is no previous value, so that's going to be null in that case. Now, I want to create another column here, and that's going to be called popularity increase. And that's going to be the increase in popularity between the current row and the previous row. So essentially, if we just comment this out and execute this, we want to take the current value and we want to get the difference between that and the previous value. And again, we can use the lag function for this. So let's remove the comment and let's write the statement now. So we're going to take the current value in the Python column and we're going to subtract the lag over that Python column. In other words, subtract the previous value. So that's going to calculate the difference. And again, we're going to use the order by date in the over clause. So let's see what this gives us now, and don't forget to alias the result here with the as statement. We now have a column called popularity increase, and we can see the increase between the current value and the previous value here. And these look correct. For example, this one here, 2.62 minus 2.51 That's going to be roughly 0.11, which is basically what that value is. And that's going to be repeated for each row in the data frame. So we now have a way to compare the current value for Python against the previous value. And if we want to get the row that has the biggest popularity increase from one date to the next, in other words from 1 month to the next, what we can do is we can use a common table expression here and encapsulate this query. So I'm going to do that using the with statement, and we're going to call the CTE popularity increases. And that's going to be as this statement here. So we're encapsulating what we wrote before, and we're going to have the returned data here, and there's 4 columns in that, as a common table expression called popularity increases. When we have that common table expression, we can then perform another selection against that. So let's select all from popularity increases, and I'm going to paste that in here. And just to make sure it's working, let's execute this, and we get back all of the data that we got before. But now we can very easily get the maximum popularity increase here. So let's add a where clause, and what we're going to look for is the popularity increase column. We're going to set that to the maximum value over that column in order to get back that row. So let's add a subquery here. We're going to get the max over the popularity increase column from our common table expressions, which is called popularity increases. So this is a subquery in the where clause here that gets the maximum popularity increase. That's going to get the maximum value from that column. And this select statement here is basically going to return the row that contains that maximum. So let's now execute this, and we can see what we get above here. And the date that we have is the 1st of April 2020. That was the month where the popularity of Python increased the most compared to the previous month in this data. So you can see the current value of Python in that month is 29.95. The previous value was 29.28. So that's an increase here of 0.67. So that was the month where the popularity of Python increased the most. And we found this out using an SQL statement against a Polars DataFrame, using DuckDB as the underlying driver for that query. So that's very useful, and it's using some really cool modern tools in Python in order to calculate this. And we're also using some somewhat complex SQL using common table expressions here to encapsulate queries, and also using a subquery here in this select. And of course, if you have your database and you're commonly performing these kind of comparisons and analysis, you might want to extract this to a database view or a dedicated table that tracks these changes every month. And those are more like data warehousing techniques and data engineering techniques. We're not going to go into any of those, but there's different approaches for using these kind of comparisons. So one thing to take away here is that the lag function is very useful for these time series analytical queries when you're comparing the current value to a previous month. Going back to Marimo Notebooks, of course, these are SQL cells. It's very easy to add these and then use SQL to query your data frames. Now, how does this actually work? What I can do is view this as Python. So if I click that, what happens here is that we get the Python code for the SQL that we've written. So under the hood, what Marimo is doing is it's wrapping that code in an SQL function, and it's returning that value to _df. Now, if we go back to the SQL cell here, you can see that we have this output variable at the bottom. So the output variable is _df. We can actually change that. So for example, if we call it xyz, and that's not a recommended variable name, what we can do when we view this as Python is that we can see that the return value is assigned to that xyz variable. So you can actually customize your query output to be stored in a variable with a given name. Now, for the time being, I'm going to store it as _df, and we're going to move on and write another query, but I just want to emphasize that how Marimo actually uses these SQL cells is that it wraps the query in an mo.sql function. So let's go back to the cell, and let's imagine that not only do we want the month where Python's popularity rose the most, but we also want the top 5 months. So what we can do is amend the statement here. So this where clause is going to be changed. We're actually going to remove that entirely. And we're going to select all from this common table expression, popularity increases. But we're going to order the results by our popularity increase column. And because we want the months with the maximum value at the top, we're going to order this in descending order. So let's execute this, and we get the values here. And these are actually the top 5 months, and you can see they're all in 2020, 2019, and 2018. And this is maybe not a surprise, because around about this time, the popularity of Python was growing a lot because of data science and AI, and developments in those fields, and the fact that Python was pretty much the main language in that domain. So a big increase for those months, and if we wanted to limit this to the top 5, or let's say the top 10, we can add the SQL limit statement to the end of this query. So I'm going to limit that to 10 results, and then we can execute that, And we get the same top 5 here, but we only have 2 pages of data now, so we can go to the second page. And again, the biggest month increases here all seem to be around 2017 to 2020. Now, because we're using this statement here where we take the current value and subtract the previous value, there is the possibility that this will be negative. So if we remove the descending order here and just execute this query, you can see the months where Python's popularity decreased compared to the previous month. So for example, here in January 2021, you can see the popularity value is 30.21, but the previous month it was 30.61, so that represents a decrease in popularity amongst the share of those programming languages. So there's all sorts of useful analysis you could do with these SQL statements against Polars DataFrames using Marimo Notebooks. And of course you could do further analysis on this. What I want to do to actually finish this section is I want to plot the popularity changes. In other words, I want to plot this column here called popularity increase. So what we're going to need to do is take this data frame result of the SQL query and assign that to an output variable. Now we saw this here, we can assign the result to a variable. I'm going to assign it to a data frame called popularity, and if we execute that, what we can do in the cell below, which I think is a Python cell, is access popularity, and you can see that here, and it contains those columns. So basically we've taken the SQL query result and we've assigned it to another data frame. And we saw how that does that under the hood here using the 𝗵𝗽𝗀 function and assigning that to a variable. So we now have that available and we can chart things out here. So let's access that column called popularity increase in that data frame. When we execute that, we get back the result here, and this is a series of data containing the values. And this is actually limited to 10 values. So what I'm going to do is remove this. And in fact, let's remove the order by as well and the selection here. We don't actually need the common table expression for this. We can remove all of this and just get back the data frame result here, and that's going to be ordered by date. Once we've got that, you can see this re-evaluates because of Marimo's reactive nature, and we now have a series containing all 241 values when we access this column here. So now that we have the column, we can access the plotting interface on the Polars data frame, and we're going to use a line plot here to plot these popularity changes, and you can see the line chart that we get back here. And you can see these increases over time, and you can see this spike that we have here, and obviously the x-axis here should have proper dates, and if you were doing this in production you would use a proper x-axis, but the spike occurs around 2015 to 2020, and then there's a lot of variation after that, as you can see here in these popularity increases. But what we've done here is we've taken the output of these lag statements here in the SQL query against the Polars data frame. We've used Marimo to assign that to an output variable here, and then we can use that output variable and we can query the results and also plot those results, as you can see here. So for more on plotting with Marimo, you can see the previous video. What I want to do just to finish this video is show how to modify the Marimo settings. Now remember from earlier, some people seem to prefer the output of the cell to be below the cell where you write the code. So what I want to do just now is just show how we can change that. So I'll leave a link to this configuration page below the video. Marimo has 2 types of configuration, user and app configuration, and both of these can be managed in the settings menu in the Marimo editor. So let's go to the editor here, and if we go to the settings at the top right here and we go to user settings at the bottom, we have these options here, and one of them is editor options. We also have display options, and that's the one we're interested in here. One of these options, and I'm going to make this a little bit bigger so we can see it better, is the cell output area. And currently by default that's set to above, but we can change that to below. And if we do that and close the settings, you can see that this has changed. So for example, our line plot now appears below the cell. So that's how easy it is to apply configurations. And that might be what you want. Some people seem to prefer that from the previous video. So this is configurable using Marimo. And notice as well, if we go to user settings, I did show this in the previous video, but there's an AI tab. And if you want to use GitHub Copilot or other tools, you can set your keys up here, and that's going to be how you apply those. Now there's some command line tools that we can use with Marimo, so I'm going to stop the server here, and I'm going to run this command. It's the marimo config show command. When we run that, we get the existing configuration for our Marimo notebooks. I'm going to expand this so we can see it better, and you can see this appears in this format here, and you can see the display options, and the cell output has changed from above to below. And we also have other options here, for example, for completion with Copilot, currently set to false, but that's something you might want to turn on as well if you're using GitHub Copilot. Now to see all possible options, what we can do is run config describe instead, and that's going to give you all of the possible options that you can add to your Marimo configuration. Now if we go back to the documentation and scroll down to user configuration, you can actually configure this with a .marimo.toml file directly. So let's see how to do that just now. I'm going to go back to the terminal here, and if we ls this directory, we don't have that at the moment, so I'm going to add that .marimo.toml file. So we have that now, and I'm going to open this in VS Code so that we can actually edit that file directly. And once we're in this file, we can add options such as display options, and we can add these types of configurations such as cell output. I'm going to set that back to above just now in this toml file. If we save that and then restart the notebook using the marimo edit command, when we go back to the notebook, you can see that the cell output is now above the cell where we write the code. So that's how you can configure these using the user interface directly, and also for reproducible settings using a marimo.toml file. And there's other blocks that we can add here. For example, package management. We can set the manager to UV or pip or poetry and so on. So we can set a number of settings here in the marimo.toml file, and that gives you a way to reproduce these settings when you're using other Marimo notebooks. So that's all for this video. We've shown how to use SQL in our Marimo notebooks to query Polars or Pandas data frames. And we also saw how to assign the query results into a variable that we can then use in subsequent cells in the notebook. And we saw earlier on how to use window functions, common table expressions, and subqueries to perform complex SQL statements against data frames, and then assign those results and use them in other cells. And finally, we saw how to configure Marimo a little bit using the marimo.toml file, and also using the settings on the user interface. So if you'd like more content on Marimo and similar topics, let me know in the comments what you're looking for. I'm happy to make more videos on this very soon, and thanks again for watching. If you found the content useful and you want to support the channel, check out this Ko-fi page that we have here, and don't forget to subscribe if you're enjoying this content. Thanks again for watching, and we'll see you in the next video.